Welcome to A-Level and AP Physics. In this lesson, we will discuss how to sketch optical fiber, prism and glass block ray diagrams for CAIE IGCSE Physics by solving tricky past paper questions. For part 1, we need to state the angle of incidence of blue light on the glass. Now, if you look at this figure, angle from horizontal is already given to us. In order to find angle of incidence, we need to draw normal. So this is our normal line. We can find out angle of incidence. Angle of incidence is the angle between this ray and normal. So this is angle of incidence. This total angle means between this vertical line and horizontal is 90. So 90 minus 35. So this angle is 55 degrees. So this is answer for part 1. Simply we can write down this is 55 degrees. For the second part, refractive index of the glass is given. So this is refractive index of the glass. We can simply say this is Ng is given. This is equal to 1.5. But refractive index of air is equal to 1. So these informations we need in order to calculate angle of refraction of light in the glass. Let's say this is medium 1 and this is our second medium. Then we can write down Snell's equation, N1 sine of theta 1 has to be equal to N2 sine of theta 2. In this case, N1 for air, this is equal to 1. Simply we can write down this is 1. And sine of theta 1 is equal to 55 degrees. We can write down here. N2 is equal to 1.5. This is refractive index of glass, and theta 2 we have to find out. We can write down theta 2 has to be equal to sine inverse of sine of 55. So this is sine of 55 divided by 1.5. Simply if we solve this one, we can find out value of angle of refraction. So that will be equal to 33 degrees. So our answer for this one is 33 degrees. For third part, we need to continue the incident ray until it emerges out of the block. It simply means that until it appears on this side. For that purpose, we need protractor because we need to draw angle of refraction and refracted ray. Angle of refraction is given. We have already calculated. This is equal to 33 degrees. So it means we have to measure angle from vertical, and that has to be equal to 33 degrees. So this angle is 33 degrees. We can use a different color for refracted ray. Let me use the blue one. So this is our refracted ray at angle of 33 degrees. So this is how you can draw. Again, we need to draw normal line. I will be using yellow color for that. So we have to draw the normal line at this point. Little adjust so it looks little better. So this is our second normal line. We need to understand, as this block, this is rectangular block, and this side of the block and this side, these two sides are parallel. So due to geometry of the shape, our incident ray means this ray, let me use different color for incident ray. So this is our incident ray and emergent ray. These two rays have to be parallel. So we can take our incident ray from here, we can place here. So this is our emergent ray. Incident ray and emergent ray, they must have the same angle from normal and they have to be parallel. That's all what we need to do for this question. But also we need to draw direction of travel of rays. So we can use the small arrows. Now this angle, for example, this is also 55 degrees. We can also label this one. This is also 55 degrees. This question is about optical fiber and it is based on concept of total internal reflection. Total internal reflection simply means that light will be totally internally reflected. It will reflect in the same medium, and light will not be able to escape the medium if angle of incidence is greater than critical angle of the medium. And the second condition is that light has to travel from denser to less dense medium. For this question, we need to draw the reflected rays inside the medium, means inside the fiber. So this is how we can draw normal to this surface. So this is our normal line. Now we need to use protractor to measure the angle of incidence and then angle of reflection. First of all, we need to align over protractor. You can see this is how you need to align this one. Little bit you can adjust. This is how you need to align your protractor with the normal line. Then you need to find out angle of incidence. In this case, angle of incidence is about 64. So angle of reflection also has to be 64. So this is angle of reflection and this is 64, about 64 here. So this is about 64 here. We simply need to draw the reflected ray. So this is how you can draw the reflected ray. We can make it little short so it has to touch the surface. So this is reflected ray. We need to draw another reflected ray because question is asking us to continue ray xy until it passes it passes this point. For that purpose, we need to draw another normal at this point. Means we need to draw the normal line. So this is about 90 degrees. Again, we need to take our protractor and we need to measure angle of incidence. So we need to place our protractor like this. We need to align this one with 90 degrees. We need to find out angle of incidence. In this case, angle of incidence is about 167. So this is about 167. So we can place like this. This is about 168. So angle of reflection also has to be about 168. So it has to be about 168. So this is 168. So we need to draw reflected ray at this point. So this is our reflected ray. We can little bit adjust until it touches the surface of fiber. So at this point it is touching the surface of the fiber. So this is our second reflected ray. Again, we can remove our protractor, but still it is not passing this point Z. So we need to draw another normal at this point. We have to draw another normal. So this is how we can draw the normal at this point, and this angle is about 90 degrees. We need to take our protractor again. We have to place here. We need to align with 90 degrees. This is how we can align. You have to little bit adjust this here. So this is exactly how we can align. We need to find out angle of incidence. Angle of incidence in this case is about 169. So angle of reflection also has to be 169.6. So it has to be 169.6. So this is 169.6. So this is our third reflected ray. We can use blue color and we can draw third reflected ray. So this is our third reflected ray. This is how we can draw reflected rays. But still this is not complete. We need to draw arrows, direction of travel. So this arrow you have to add here, and we need to add arrow here as well. We can also make the normals at dotted lines. So this is our normal. We can make this one as dotted line. We can also make this one dotted line. This is dotted line. This one also dotted line. For this question, a ray of monochromatic red light in air is incident on a glass block at an angle of incidence of 50 degrees. This is what is given to us. You can see here, this is a glass block and angle of incidence of red light is given. This is 50 degrees. For this question, without measuring angles, we need to use a ruler to draw the approximate path of the ray in the glass block and also emerging from the block. Let's try to draw the path of red light, means the refracted ray we need to draw. Look at this one. If there is no change in medium, this light will just go in a straight line. But in this case, there is a change in medium and light is entering into a denser medium. It simply means that the light will bend towards normal. It will bend like this. This is how it will bend. We need to draw another normal at this side, and then we need to draw the emergent ray. So this is our normal at this side. We need to draw emergent ray. Before we draw emergent ray, we need to understand the shape of this block. This is rectangular block and its two sides, this side, they are parallel to each other. It simply means that the emergent ray here and incident ray, these two rays, they will be parallel to each other. We can draw incident ray here, then we can move this one from here to here. So we can make it little short. So this is our emergent ray. It simply means that the angle of emergent means this angle. This is also 50 degrees because this angle is also 50. We can also draw small arrows to show direction of travel of light. So this is how we can draw small arrows. For part 7b, it is given to us that red light is replaced with violet light. Angle of incidence and glass block, they are the same. Now, first of all, we need to understand which one has higher frequency. Red light has higher frequency, or the violet light, it has higher frequency. Violet light has higher frequency. If the frequency of the light is higher, that light bends more, means refract more. So in this case, violet light, this will bend more. So this is the key concept, and rest of the steps, they are the same. Based on this concept, let's try to draw the path of violet light. We will use this pink color for violet. So this is refracted ray, means this is bending more. We need to draw normal at this point. This is how we can draw the normal. Again, we need to draw the emergent ray. We need to understand angle of incidence is the same, so angle of emergence also has to be the same. So we will follow the same step. We will draw our incident ray here, and then we will move this one from here to here. So this is our emergent ray. We can also add small arrows. So we can add small arrows to show direction of travel. You can see here these two rays are parallel. Why? Because this is due to geometry of the shape. This question is very similar to the last one. Only difference is that in this case we have this triangular prism, but in the last case we have rectangular glass block. Rest is the same. For this question we have two lights. One is the red one, the other one is a violet light. For the red light, we need to complete the path of the red light. So we need to draw the normal first of all. So at this point we can draw the normal. For normal line we can use green color. So let me draw here. So this is how we can draw the normal on this side. Can make it a little bit short. So this is our normal line. Next we need to draw how this will refract. This will refract away from normal because it is entering less dense medium. This will bend like this. So this ray of light, this is gonna bend like this. So it will bend away from normal. So we can draw like this. So this is what we need to draw for the red light. Now we need to draw for the violet light. Violet has higher frequency, so it means violet will bend more, will refract more. So this will bend like this. Again, at this point we need to draw the normal, so we can draw normal again. We will use green color, so we can draw the normal line. So first of all, let me move this one here. At this point we can draw the normal line here, so let me make it shorter. So this is our normal at this side. Emergent ray, it is entering less dense medium, so it will bend away from normal. This is violet light, so it will even refract more than red, so it will bend somewhat like this. So it will bend somewhat like this. It will bend more than red. So this is how you need to draw red and violet light. We can also use small arrows to show direction of travel. So these arrows are also important. We can draw these arrows here. For this question on figure 7.1, we need to draw carefully without calculation the continuation of the ray through the prism and into the air. But for this question, refractive index of glass is given, that is 1.5, and critical angle for glass air boundary is also given, and this is equal to 42 degrees. In order to draw this incident ray, this is entering at angle of 90. This is parallel to the normal, so this will just go in a straight line. So simply we need to draw this horizontal line. This is what we need to draw. So this is horizontal line we need to draw. Now at this point, this is very important point, because critical angle is 42 degrees. We need to draw the normal line, and then we need to find out angle of incidence. So this is very important point. So let's try to draw normal at this surface. So this is our normal at this surface. We can little adjust this. This is quite good one. So this is our normal. Now we need to find out angle of incidence. Angle of incidence. In order to find angle of incidence, we can rotate this and we can align this one with normal. So over normal. So let me align this. So this is how you need to align. Now we need to find angle of incidence. If you look at this angle of incidence, let me place this one here. So the angle of incidence we can find, so you can see here, this is about 60 degrees. This angle of incidence is 60 degrees, and this is greater than the critical angle. So it simply means that the light will be totally internally reflected. The angle of reflection also has to be 60 degrees. So this is how we can draw over reflected ray. So we need to draw here. So this is over reflected ray, but we can make it shorter until this side. Until this side we can make, let me remove this and a little bit extend. So this is our reflected ray. Now we need to draw another normal on this side. So let me draw the line here. So we need to draw another normal on this side. So this is our normal on this side. We need to measure angle of incidence. So you need to align your protractor with normal, and then you need to find out angle of incidence. So we can align like this. So we can place our protractor at this point, and we can find the angle of incidence for this reflective ray. Angle of incidence in this case, this is about 32 degrees. Angle of incidence is about 32 degrees. Now we need to calculate angle of refraction. Angle of incidence we have already found. This is equal to 32 degrees, and the refractive index of glass means N for glass, this is given in question, that is equal to 1.5, and our next medium, this is air. For air, value of N for air, we can say A, this is equal to 1. Now we need to use Snell's law to calculate angle of refraction. We can simply use Snell's law. According to Snell's law, N1 sine of theta 1 has to be equal to N2 sine of theta 2. In this case, this is our medium 1 and this is our second medium. For medium 1, value of N is equal to 1.5, and angle in medium 1, this is equal to 32 2 degrees. In second medium, value of n means the refractive index of A, this is equal to 1, and this angle we need to find, sine of theta 2. We need to find out theta 2, we can write down, this will be equal to sine inverse of, so this is sine inverse of 1.5 times sine of 32 degrees. If we do these calculations, our final answer will be approximately 53 degrees. Simply, we need to draw emergent ray at an angle of 50 degrees with this normal. So we need protractor. So let me place our protractor here at this point. Angle of 53 degrees, it means about this. So this is over emergent ray. So this is emergent ray around 53 degrees. This is how we need to draw. Simply, we can add small arrows. Let me use different color. Let me use blue one. We can use small arrows to show direction of travel. So these arrows are also very important. So we can simply draw these arrows here.